A garage door opener is a motorized device that opens and closes garage doors. Most are controlled by switches on the garage wall, as well as by remote controls carried by the owner. The electric opener. The electric overhead garage door opener was invented by C.G. Johnson in 1926 in Hartford City, Indiana. Electric garage door openers did not become popular until Era Meter Company of Chicago offered one after World War II, where the overhead garage door could be opened via a keypad located on a post at the end of the driveway or a switch inside the garage. Contrary to popular belief, the electric opener does not provide the actual lifting power to open a heavy garage door. Instead, most of the actual lifting power comes from the counterbalance springs attached to the door. These springs are under tension to lift the garage door via steel counterbalance cables. The electric opener provides only a small amount of force to control how far the door opens and closes. In most cases, the garage door opener also holds the door closed in place of a lock. The typical electric garage door opener consists of a power unit that contains the electric motor. The power unit attaches to a track. A trolley connected to an arm that attaches to the top of the garage door slides back and forth on the track, thus opening and closing the garage door. The trolley is pulled along the track by a chain, belt, or screw that turns when the motor is operated. A quick release mechanism is attached to the trolley to allow the garage door to be disconnected from the opener for manual operation during a power failure or in case of emergency. Limit switches on the power unit control the distance the garage door opens and closes once the motor receives a signal from the remote controller wall push button to operate the door. The entire assembly hangs above the garage door. The power unit hangs from the ceiling and is located towards the rear of the garage. The end of the track on the opposite end of the power unit attaches to a header bracket that is attached to the header wall above the garage door. The power head is usually supported by punched angle iron. Recently another type of opener, known as the jack shaft opener, has become more popular. This style of opener was used frequently on commercial doors but in recent years has been adapted for residential use. This style of opener consists of a motor that attaches to the side of the torsion rod and moves the door up and down by simply spinning the rod. These openers need a few extra components to function safely for residential use. These include a cable tension monitor, to detect when a cable is broken, and a separate locking mechanism to lock the door when it is fully closed. These have the advantage that they free up ceiling space that an ordinary opener and rail would occupy. These also have the disadvantage that the door must have a torsion rod to attach the motor to. Remote control. The first wireless garage door openers were invented and developed by two U.S. inventors at the same time, one in Illinois and the other in Washington state. They were unknown to each other. The first garage door opener remote controls were simple and consisted of a simple transmitter and receiver which controlled the opener mechanism. The transmitter would transmit on a designated frequency. The receiver would listen for the radio signal, then open or close the garage, depending on the door position. The basic concept of this can be traced back to World War II. This type of system was used to detonate remote bombs. While novel at the time, the technology ran its course when garage door openers became widely available and used. Then, not only did a person open their garage door, they opened their neighbor unregistered trademark garage door as well. While the garage door remote is low in power and in range, it was powerful enough to interfere with other receivers in the area. The second stage of the wireless garage door opener system dealt with the shared frequency problem. To rectify this, multicode systems were developed. These systems required a garage door owner to preset a digital code by switching 8 to 12 DIP switches on the receiver and transmitter. While these switches provided garage door systems with 28 equals 256 to 212 equals 4096 different codes, they were not designed with high security in mind. The main intent was to avoid interference with similar systems nearby. Criminals were able to defeat the basic security of this system by trying different codes on a regular transmitter. They could also make code grabbers to record and retransmit a signal, or code scanners, that would attempt every possible combination in a short time. Multicode openers became unpopular in areas where security was an issue, but due to their ease of programming, such openers are often used to operate such things as the gates in gated apartment complexes. An intermediate stage of the garage door opener market between the second and third stages eliminated the DIP switches and used remotes pre-programmed to 1 out of roughly 3.5 billion unique codes. This system was backward compatible with the DIP switch remote codes, and each remote code can be added into the receiver's memory by pressing the Learn button on the opener, and can be deleted from the receiver's memory by holding it. While the code transmitted by the remote was still fixed, it was not changeable by the user and thus was much more difficult to duplicate unless two remotes shared the same code. This approach was an improvement over the fixed DIP switch codes, but was soon rendered obsolete when rolling code devices became available. The third stage of garage door opener market uses a frequency spectrum range between 300 to 400 MHz, and most of the transmitter receivers rely on hopping or rolling code technology. This approach prevents criminals from recording a code and replaying it to open a garage door. Since the signal is supposed to be significantly different from that of any other garage door remote control, manufacturers claim it is impossible for someone other than the owner of the remote to open the garage. When the transmitter sends a code, it generates a new code using an encoder. The receiver, after receiving a correct code, uses the same encoder with the same original seed to generate a new code that it will accept in the future. Because there is a high probability that someone might accidentally push the open button while not in range and desynchronize the code, the receiver generates look-ahead codes ahead of time. Rolling code is the same method of security used on the clickers of cars, and with some Internet protocols for secure sites. The fourth stage of garage door opener systems is similar to third stage, but it is limited to the 315 MHz frequency. The 315 MHz frequency range avoids interference from the land mobile radio system used by the U.S. military. The following standards are used by units manufactured by Chamberlain, does not apply to keyless entry keypads or universal remotes. The following standards are used by units manufactured by Overhead Door Corporation and its subsidiary the Genie Company. Note: there are no standard color codes for the Learn button or LED on units manufactured by Overhead Door or Genie. All accessories made for later versions of Genie IntelliCode and Overhead Door CodeDodger are backward compatible with previous generations of IntelliCode and CodeDodger. Cloning garage door opener remotes. Many garage door opener remote controls use fixed code encoding, which use DIP switches or soldering to do the address pins coding process, and they usually use PT2262 per pint 2272 or compatible ICs. For these fixed code garage door opener remotes, one can easily clone the existing remote using a self-learning remote control duplicator which can make a copy of your remote using face-to-face copying. Additional features that have been added over the years have included automatic courtesy lights that turn on when the door opens and automatically turn off after a preset time delay, a remote lockout feature, which turns off the radio receiver while one is on vacation or away for an extended time. The availability of accessories has increased, including such features as wireless keypads, keychain remotes, and solenoid-operated deadbolts to lock the door itself. More sophisticated features are also available, such as an integrated carbon monoxide sensor to open the door in case of the garage being flooded with exhaust fumes. Other systems allow door activation over the Internet to allow homeowners to open their garage door from their office for deliveries. Another recent innovation in the garage door opener is a fingerprint-based wireless keypad. This unit attaches to the outside of the garage door on the jamb and allows users to open and close their doors with the press of a finger, rather than creating a personal identification number. This is especially helpful for families with children who may forget a code and are latchkey kids. Safety: the garage door is generally the largest moving object in a home. An improperly adjusted garage door opener can exert strong and deadly forces and might not reverse the garage door in an emergency. The garage door counterbalance springs should be properly adjusted in order for the safety reverse system to function properly. Thus, Proper installation and maintenance are extremely important in order for the garage door and garage door opener to operate smoothly and safely. The header bracket, which attaches the front end of the opener track to the header wall, must be securely attached to the structural members of the garage wall. If not, the opener might not reverse the garage door in an emergency. The rail can also pull away from the wall. All garage door openers manufactured and installed in the United States since 1982 are required to provide a quick-release mechanism on the trolley that allows for the garage door to be disconnected from the garage door opener in the event of entrapment. The quick-release handle should be mounted no higher than 6 feet from the ground. Homeowners should be familiar with this mechanism, because garage door springs can relax over time, and pulling the release could lead to a free-falling door. Garage door openers manufactured since 1982 are also required to reverse the garage door if it strikes a solid object. The wall console push button should be mounted at least 5 feet from the floor and the remote controls should be kept out of the hands of children. Children should never be allowed to play with or use the garage door opener remotes or wall push buttons. Homeowners should also keep a moving door in sight until it fully opens or closes. Under U.S. federal law, garage door openers manufactured for the U.S. since 1993 must include a secondary safety reversing system, such as photoelectric eyes or sensors, mounted no higher than 6 inches above the ground, or an electric safety edge mounted on the bottom of the door, which upon contact reverses with about 15 pounds of pressure. Other approved systems, by Martin Door Manufacturing and Wayne Dalton, have a garage door and opener system, UL 325 listed, which reverse on the same 15 pounds of resistance, without photo eyes or the electric safety edge. Other examples of safety reversing systems, allowed within the guideline of UL 325, include electric safety edges, which reverse with approximately 15 pounds of downward pressure, and a garage door and opener system without photo eyes, tested together, which reverses upon approximately 15 pounds of pressure. References. External links, official FCC notification on garage opener frequencies, garage door opener safety tips, Safety Commission rules for automatic garage door openers, U.S. Consumer Product Safety Commission. CPSC, 1992.